In this video, you will be learning about phase diagrams. So, what is a phase diagram? A phase diagram is a graphical representation of the physical states of a substance under different conditions of temperature and pressure. Typically, pressure is on the y-axis and temperature is the x-axis. First, you have the three regions. These regions represent conditions at where that particular state is stable, these states being solid, liquid, and gas. These states are divided by the three curves. Each of the lines in the diagram represents a set of temperatures and pressures where the substance is in equilibrium between the two states on either side. These curves are known as the fusion curve, the sublimation curve, and the vaporization curve. Next, you have the triple point. This point represents a temperature and pressure at which the solid, liquid, and vapor phases of a pure substance can coexist in equilibrium. Lastly, we have the critical point. The critical point is a point on a phase diagram at which both the liquid and gas phases of a substance have the same density and therefore are indistinguishable. This is also known as the supercritical fluid. I will now show on the graph where these are located. Now, let's take a look at a phase diagram for water and carbon dioxide. Most diagrams have a fusion curve that is positive, like carbon dioxide's, because increasing pressure favors the denser state. Water does not, though. That is because the behavior of water is atypical. The slope of the fusion curve of water is negative because water is denser than ice. I wanted to show you carbon dioxide's curve because unlike water, CO2 does not have a stable liquid state at 1 atm. Solid CO2 is dry ice, so until you reach 5.1 atm, the solid will sublime into gas as temperature increases. It will only form a liquid at pressures above 5.1 atm.